Alright, so I got this thing running now. Here's the setup. Let me stop this for a second. I got 3 magnets on here that dump and fill every third of a revolution, and then 1 small magnet on the inside that pulse drives 3 coils once per revolution. The other 3 coils are always capturing. I'm trying to add on some sort of diode plug circuit or back EMF circuit off the coils I'm using to drive it, but for now that's what I got. So there's the ammeter, it's at 0. I'll start it up here in front of you. So I got 24 two 12-volt batteries wired in series. Little gel cells are 24 volts total. You can see ammeters, I mean, it's pretty much nothing. There's the little gel cells. How I have it set up with the solid state relays here. I'll stop this again. Hopefully you can see the little lights on there. That's how they're both set up. So if you see it's filling, there's a delay in there where they're both off. Then this one's on, it dumps that cap, stops, goes back to filling the rest of the revolution. The other solid state relay pair down here do the same thing. There's 2 MOSFETs and a little driver, pulse driving the coil. I'll start this back up again. I'll take a quick RPM reading. Well, I'll try to. This ain't working right now. Alright, somewhere between 363 and 1,000. I'll have to look at the frequency. I'm getting close to 1,000, but basing off of sound, I don't think so. Let's go into a capacitor bank down there. Zoom in on the scope. There's a sine wave. Doesn't look very good. So this guy's running here. So there's the 4047 circuit with the 10 MOSFETs, a bank of wires. So here's what I'm mainly getting at. There's a sine wave. We'll zoom in on this a little bit. Now that's without the shorting. I'm going to turn on the shorting here. And you can see, I'm going to adjust the pot down a little bit. Move the window. Bigger, less. The gating doesn't seem to do too much, the oscillation pulsing, until you get to a higher RPM, when the window's a little smaller and whatnot, but at the lower RPMs it doesn't seem to help quite as much. I'm turning it right now and you can notice a little bit of difference, but more so at the higher RPMs. Let me move the scope. Now there's the right now this is the capacitor bank that we're filling on the 3 coil sets. I'll mention too quick, the bridge I paralleled with a bunch of diodes, maybe 4 on each, and it does help the output a little bit. Again, more RPMs, the more it seems to help, which makes sense. So there's the capacitor without coil shorting. Now I'm going to turn this on. So you can see it goes up definitely a little bit with the coil shorting. And I don't know coming through interference wise or whatnot, but I'm going to turn this off. So it's definitely noticeable. But the thing is, let me put this back on the coil. Alright, so there's the coil. Now I'm going to turn on the coil sorting. you can see that I'm only sorting this peak, and this peak. Due to how many magnets I have, I need to change that. So I'm skipping 2, pulsing 1, skipping 2, pulsing 1. Now on the other side, which would be the opposite polarity on the magnets, I'm not sorting any of them. So that noticeable improvement doesn't add any load to it, and I can add a lot more coil sorting. So I'd expect my numbers to go up considerably more, but I'm not sure where I'm at right now because I'm driving it from the 2 batteries. It's not really drawing much amp draw, and it's pulse driving it, so I'm not sure if I can use a shunt on something like that or just calculate the pulse width per minute. I don't think that's going to be accurate using a battery. I don't know if anybody's got any ideas, but so I'll show some of these prints that I have. So I can zoom in on this so you can see a little better. Off, on, move the window down, turn off the gating, and back on. You know, the other one I can move this forward or back, but it's definitely right in this range. So at the lower RPMs, I could actually widen this a lot more, even with no real noticeable load on it. So I was going to show these. This one was one that Silver did a while ago. I did make a print for that if anybody needs it. But right now I'm sticking to the 4047 circuit. Here's another one that I ran across. I guess I'm wondering if anyone has any recommendations on the bifilar winding, like a 1-to-1 ratio, 3-to-1 ratio on the pulsing side versus the recovering side, and wire gauge size, wire size. Should it be a little bigger on the side you want to recover on, or a little bigger on the side that you want to pulse? Is there somewhere that's better? Also, I wonder if it's beneficial to have these high-pass filters on there, or not. I guess I'm not real familiar on how that would help it. If anyone has a suggestion. This seems to be a pretty complete circuit, except for the fact that I don't have bifilar coils. Food for thought, and I'm kind of doing this just as a recap for myself, so if I ever need to look back at this video, I can do so if I lose my notes or whatnot. Here's a Bendini one that I found. This looks kind of cool too, although I don't know the rest of the circuit. AC line coming in, I'm assuming should be isolated somehow when it's discharging, unless it's on a negative peak, but that shouldn't matter because you have a bridge going to it, so I don't know. Maybe someone can enlighten me. I was going to mention this one to Silver if you're out there. This was that H-bridge circuit I was working on. I have a PCB in the files for this one, and I didn't fire it up yet, but I quadruple checked it, and it's exactly according to this, but doubled up with some MOSFETs. Now what I was trying to do with it was, I think this is the layout of one of them. I'm trying to just break this up so that instead of it, you know, going like that and then like that to route the electricity different ways, that you would just drive through and your cap would be like, let's say, in the center. So you had your coil and the voltage came in, filled a cap there, and then stop there, and then we activate these two, moving that cap load over to the capacitor, what's in the capacitor, moving it over and into the load here. So out and then into here. So we fill one, then dump that one into the other load over on this side. You could probably use the same drivers, just move them around. So instead of like this, it's these two, then these two. Then you could use some N-channel MOSFETs because you're floating around, I think. Other thing I was going to mention to you guys was the multiplier circuit. Is there a recommended value for these, or what roughly might I want to use on something like this? I'm thinking 3500 volts DC is probably going to be a bit much, but I don't know, maybe not if it's just at 10 microfarads or something, I'm not sure. I was looking at some of Cone's stuff here. I was going to ask you the same thing on the AC cap. It looks like a high pass filter. Why? I guess why are we putting this on there? Why would it matter? Are you just using this to assure it's, I don't know, you don't pick up any stray frequency, like on your scope or something like that? I'm not sure. Other thing I was going to mention was on this one. Is this diode in the right place? That seems, because when you break here, you would have a big inductive spike coming back, be able to fill this cap, but on this side you would have nothing going into this, which is fine, maybe. But on this one it's different, because you're breaking it there, so your diode's in between the break and the coil. So I'm not sure if that one is correct or not. Kind of go through. Oh, was this? I'm not even sure if this was yours, Doug's, but did this circuit work? If anyone out there has used this one with the PNP or P-channel MOSFETs going into the other P-channel MOSFETs, I think that's it on this one. I mean, I have the coil shorting is very easy, but I don't like the fact that the SSR seem to snuff out a fair amount of ringing on the different ones that I've used. Here's another solid state relay print. Now this one, I cannot get this working. Have you tried this circuit, or anyone? And if so, maybe this is a bifilar, supposed to be a bifilar coil. Because once I activate this, or if it's in the circuit the whole time, as soon as I go to dump this into the other cap, I've tried this, and it lugs this down horribly. So I know when I'm pulse driving the coil, it's also filling this all the way. So maybe I'm doing something wrong as usual. In this circuit, I'm not sure if this is correct, because I'm trying to think of it in the terms of when it releases. So, okay, you pulse drive this coil, now the back EMF or inductive spike comes back. Okay, it can go back into the plus, and then on this side, it's going into the negative. When you're, I guess I'm not understanding why you have the diode, for example, on this. When would it ever, so positive out of the cap can't go this way, positive out of the cap can't go that way. I'm not sure what I'm missing here. If you might be able to maybe point me a little bit closer. And I was trying to, why is it advantageous to use high voltage DC on this in the first place? I've seen on the fuelless motors, they seem to work really good. And this was kind of what I was getting to on the bifilar coils for pulse driving the coil and recovering. Would you want, more turns on one side versus the other if it wasn't clear what I was getting at? The back EMF thing, I'm not sure what's going on there either, but I figure it might be kind of cool just to see the coil shorting in action. So there's an on, off. That's it. Any questions, let me know. Thanks, guys.